This is the screencast for section 2.2, example 4. We are now going to graph some power functions. Monomial functions were pretty easy to graph because they were just x to the first, x squared, x cubed, x to the fourth, etc. Power functions get a little bit trickier. We've got decimals, we've got fractions, we've got positives, we've got negatives. We've also got categories that determine the basic shape of every single one of those graphs, every single one of those combinations. So, first, let's look at those categories. They're over here in this graph right here. If your exponent is negative, the graph will always look, of a power function, will always look like this in quadrant 1. Similar to your basic function 1 over x. If the a value equals 1, so if your exponent equals 1, your graph will look like this, which is a line. You already know that. X to the first graphs to be a line. If your if your exponent is greater than 1, so like x squared, x to the third, x to the fourth, x to the fifth, x to the 9 halves, x to the 1.3, the graph will always look like this in quadrant 1. If your graph is, if the exponent is between 0 and 1, so like 1/3, 1/2, 0.8, the graph will look like this, like your basic square root function, x to the 1/2. Then if your leading coefficient or your k value is negative, those just get flipped over into quadrant 4. So this chart isn't telling us much, anything new, it's just telling us about the vertical flip. So let's try some. In example 4, state the values of the constants k and a. So I can do that for part A right now. First of all, k equals 2, a equals -3. Describe the portion of the curve that lies in quadrant 1 or quadrant 4. Okay, well this one's going to land in quadrant 1 because k is positive. It is not getting flipped over the x-axis. A, the exponent, is -3. So that falls under the negative category, which means the graph is going to look like our basic function 1 over x. So far, I already know what the right side of the graph is going to look like. It's going to have this shape. Then the directions say determine whether f is even, odd, or undefined for all negative x values. So we still don't know what's going on that left side. And then it says describe the rest of the curve, if any. Graph the function to see whether it matches the description. Alright, so far the right-hand description looks like this, or sketch looks like this. Now I'm going to test the function to see whether it is odd or even. 2 times, let's see, -x to the -3rd. Okay, a negative exponent I know moves whatever the base is down to the denominator, so this can change to 2 over -x now to the positive third power because the negative exponent moved it down to the denominator and became positive. Now a negative cubed is still a negative, so now I have 2 over -x cubed, which is the opposite of what I started with. I had positive 2x to the -3rd power. This is -2, the negative sign with the 2, and then x to the, see how x to the third is in the denominator? That would be x to the -3rd power if you wrote it all in a row. So this function is in fact odd. Therefore, the rest of this graph, we now know what it looks like. So here's the graph. I zoomed for, or zoom forward, I don't know, to show this in a window that's a little bit easier to see. But basically we did graph this correctly. It has the shape of 1 over x on the right hand side in quadrant 1, and then the function is odd. The part A, f of x, is odd, so the rest of it would be in quadrant 3. Now let's look at B. Alright, B's k value is negative. -0.4. So now I already know right off the bat, I'm thinking, okay, the right side of this graph is going to be in quadrant 4, not quadrant 1. It's going to be flipped over the x-axis. The a value is 1.5 or 3/2. As a matter of fact, I'm going to write this function differently. I'm going to write this as negative 0.4, and then instead of x to the 3/2, I know that that means negative 0.4 times that would be the square root of x cubed. So that would be like there was a little 2 there with the square root. The denominator of your exponent is the root. The numerator of your exponent is the power. So now, in my sketch, the exponent is between, it's a fraction, but it's not between 0 and 1. It is actually greater than 1. It's 1.5. So the function is still going to look like y equals x squared, which also has an exponent greater than 1. X cubed also looks like this to the right. X to the 4th also looks like this. X to the 1.5 therefore will look like this in quadrant 1. Now since my k value is negative, I'm going to flip that over to quadrant 4. Now I need to test whether this is odd or even. So f of negative x, and we'll see what happens. I'm going to plug that in. Let's see. I'm going to plug that into this one down here so that I can see, I have a better idea of what's going on with all those roots and exponents. Now a negative cubed is still a negative. And I can't take a square root of a negative. That's actually does not exist. So the left side of this graph will not exist. There is no left side. And I'm going to prove it to you. Negative 0.4 x to the 1.5 graph. Nothing on the left. There it is. Right side only. I'll zoom 6 so we can see that a little bit farther away. Only the right side, and it's a stretched out parabola. It's skewed a little bit, but it definitely looks like a parabola there on the right. Now part C, that would be, let's see, I'm going to rewrite this so that I have a better understanding of what's going on. This is negative x to the, let's see, 0.4 is 4/10, reduce that as 2/5. Which means this is negative and then the 5th root of x squared. 5th root of x squared. Okay, so thinking about the right-hand side of this graph, the exponent is 2/5. That's between 0 and 1. So that's going to look like my square root basic function because that would have the exponent of 1/2 also between 0 and 1. So the right side is going to look like this. Now that k value is negative. I actually need to write those down. K equals -1. A equals 0.4 or 2/5 would be just fine. So now the right side of the graph is no longer going to be in quadrant 1. It's going to be in quadrant 4, flipped over the x-axis. I got to see what happens on the left-hand side. So I'm going to plug in f of negative x into the one with the expanded root and exponent so I can see what's happening with those roots and exponents. 5th root of negative x squared. Oh, that was messy. Sorry, let me change that out. Now when I square a negative, I get a positive. So after the simplification and plugging in negative x, I get the same thing as if I plugged in regular x. So this is an even function. Which means the left side is going to be symmetrical to the y-axis on the right side. Let's graph in the calculator to make sure. Let's see here, I've got negative x to the 0.4. Here's zoom 6. You can kind of see the bowing of the graph. It looks like a square root function, but even, symmetrical about the y-axis. Let's zoom 4 to see that a little bit closer. There, now it's very obviously similar to that square root function, and as we said before, symmetrical to the y-axis, so even. The now try problem is number 43. State the values of the constants k and a. All right, I can do that. That's the easy part of this, right? So k equals 3, a equals 1/4. Describe the portion of the curve that lies in quadrant 1 or quadrant 4. So quadrant 1, our graph is going to be in quadrant 1 because k is positive, so the graph is going to be up here. Now our exponent is between 0 and 1. It's only 1/4. So very similar to example C in the last problem, the right side of the graph is going to look like the square root function that also has an exponent of 1/2. Now we got to figure out what's going to happen on the left side. So I'm going to plug in negative x. Now I didn't rewrite this originally, but that is just the 4th root. So the 4th root of negative x, 1/4 power is the 4th root, or the 4th root of negative x to the 1st power, which wouldn't make a difference. I can't take an even root of negatives. So the left side does not exist. So I think this is the only graph that is going to occur is on the right hand side, and it's going to look like the square root function in quadrant 1. Let's check it out. 3x to the 1/4. And let's graph that. There it is, no left side, just the right side. Let's zoom 6. Apparently I'm thinking upside down today. There we go. So now the right side of the graph took on the shape of x to the 1/2 because the exponent fit the same category between 0 and 1.